Now we want to look at these algebraically. So now we're going to actually pay attention to what the actual equation is. So if I go back to the beginning one, number 16. And I want to actually, if I'm just looking at this, I don't have a graph, okay? I want to find the x-intercept and the y-intercept. One of them is really easy, and we've really been doing it with the chart with a line anyway, but now we got all these other functions. The first one that's really easy is the y-intercept. Algebraically, to find the y-intercept, you just let x equal 0 and see what you get. Okay? So for number 16, if I put in 0, I end up with the square root of -1. Can I do that? Not in the real number system. So that means there is no y-intercept. Does that jive for what we have? Yes. So that's how we would prove that. The second one is the harder one. It's the x-intercept. What you actually have to do is solve this darn thing. You got to set it, the whole thing equal to 0 and solve for x. And for us, that's going to require about 4 different types of techniques in these 8 problems. Okay. So for number 16, if I've got this, the x-intercept, I'm going to put 0 equals the square root of x minus 1. Now, square roots. Anybody remember how to solve stuff with square roots? Got to square both sides, don't we? Got to get the square root all by itself, and then we got to square both sides. So if I square 0, I get 0 still, right? And that's x minus 1, because when I square root, or square root, it goes away. There's no plus or minus when you square. Only when you take the square root do you plus or minus. And so when this is all said and done, I turn that over, and my x-intercept is at x equals 1. And that matches up with what we had. Now, looking at number 17, life's going to get a little more challenging. Give me some room here. Here's the equation. To find the y-intercept algebraically, I plug in 0 for x, right? So I plug in 0, I get 0 minus 0 minus 0, which is 0. So my y-intercept is 0, 0. Did that match with what we had? Yeah. Now, there's 3 x-intercepts because we know there's 3 solutions. But that doesn't always, there's always match up, so just be careful of that. We'll learn that, go back to that again. But now I got to solve this. I've got to take 2x cubed minus x squared minus 3x equal to 0. This should scare you a little bit because it's a cubed. But, anybody see anything we can do first before we try and solve this thing? Take out what they have in common a little bit. Factor that out. If I take out an x, 2x squared minus x minus 3. That works. So I've got one of the factors now. Hey, this is my standard everyday quadratic, isn't it? So now I just got to make the front on that thing. Make the back. So I need a 3 and a 1. But they all have to add up to -1. If I put the 3 here, that makes 6. That's probably not a good spot. So I'm going to put the 3 there and the 1 there. So now that's 3x in the middle and 2x on the outside. That's probably going to match up. So I need the -3x and the +2x. And that makes my -3, makes my 2x squared, and it works wonderful. And then I would take each individual one and look at the factors. There's my -1, there's my 0, and this was that one I was talking about. Three halves. So that's how you're going to prove it. Kind of walk through a couple of these together. So if I've got the cube root of x for number 18, I plug in 0, I get my y-intercept is 0, right? Now if I got to solve it, I get the cube root of x equal to 0. Well, how do you make cube roots go away? How did I make square roots go away? Squared both sides, right? If I want cube roots to go away, I can cube both sides. So 0 cubed is still 0, and there we go. Done. (19). It's got a square root. We're going to be careful here, so we'll watch what happens. Plug in 0 to find the y-intercept, and I get 3. But now I've got a square root. Last time we had square roots, we squared both sides, but that was before it had just the square root on one side. So before I square, I have to isolate. So what do I got to do to the 3? Move them over. And now if I square both sides, I get x equal to 9. Does that match with what I had? No. Why? What happened up here? I have a square root that would have to give me a -3. What do you know about square roots? When you take a square root, the number's always positive. So when I squared both sides, I actually screwed something up or made some false statement out of that whole thing. And so you would always want to go back and check your answer with this. If I plug in 9 back to the beginning, I better get 0. And I don't. I get 6. So this, when you square both sides, you should always check, especially if there's a negative. So in reality, that ends up being no solution. But mathematically, at first it's lying to you. Then when you go back and check it, you find out the truth. (20 and 21). Those are two easy ones. They're both parabolas. I'll leave those to you to try that, because I want to focus in on number 22. So you can factor those, do all that whole stuff. You can add those in a minute. And even 23 is the same way, another parabola. You should be able to prove that. But I want to look at 22. 22's got the equation. I might as well keep it up here right away because it's going to be there. X cubed plus 6x squared plus 12x plus 8. Right away, we want to find the y-intercept. I plug in 0 for x, and what do I get? 8. Now, when we did this to begin with, this graph didn't go high enough, right? Well, where's 8 on here? Right there, isn't it? 2, 4, 6, 8. Something doesn't seem right, does it? So, got some issues. We'll ignore that for just a minute, but we know that graphically and algebraically aren't matching up right away. But now, let's see what we remember how to do. Anybody remember how to try and solve that cubic? Do they have anything in common? No, so we're stuck. Last year there was only one way he probably showed you to handle a cubic. Anybody remember? Doesn't happen much anymore because you guys all have to maintain a 6-foot spacing. Oh, you are good. Grouping. We got to take 2 of these and group them together. And hopefully they have something in common. Now, I will always try the first 2 and the second 2. Of this first group, what do they have in common? X squared, right? So I'm going to take the x squared and put it here. X squared leaves me an x and a 6. What do these guys have in common? 4, don't they? So I'm going to take a 4 out, and that leaves me with 3x and 2. That didn't help much, right? Because hopefully you're looking for these groups are the same. Well, so first and second don't work. What if I try first and third? And second and fourth? Well, these guys just have an x in common, and there's no 12 over here, so that's not going to work. And if I went first and fourth, and second and third, still got nothing. So to be honest with you, this one's really hard to do graphically with our grouping thing. Actually can't do it. So for you guys, for right now, we're kind of stuck. Right? So we really can't prove this one, and this, quite frankly, is a whole big mess with the whole graph. It should be scooted over kittywampus a little bit, and so we're going to kind of just toss it out for what we need. So we don't have to prove that at all, because it's what they have, they messed it all up. Kind of messed up all graph. So just finish up the 23, the 20 and 21 with the algebraic stuff, and then we're going to head to symmetry. We'll be out of here in no time. Next.